Hello everybody. Today from Edexcel International GCSE 9 to 1 further pure mathematics book student book, we will solve some maths from chapter 9. Chapter 9 differentiation, exercise 7. We will solve some maths. Now see how can you solve it. Okay. Exercise 7, the topic is find the stationary points of a curve and calculate whether they are minimum or maximum stationary points. This topic is very important for all of us. This is the curve. Uh, this point is maximum point, that one is minimum point. Why? A point where the gradient of fx stops increasing. Here you see the fx is stop increasing over there, here, and start decreasing, and here the decreasing. Stop increasing here and start decreasing. So this point is called the maximum point. This point is called the maximum point. And where fx is start decreasing, stop decreasing, this point, stop decreasing fx, and start increasing fx. From this point, it is start increasing fx. This point is said to be minimum point, a point where the gradient of fx, here the gradient of fx stop increasing and gradient of fx starts decreasing here. And here the gradient of fx stop decreasing here and start increasing. Gradient of fx, not fx, gradient of fx start increasing from this point. So this point is said to be minimum point. And these are also known as turning points. This point is said to be turning points. And when it's occurred, when f prime x or f prime x or dfx, differentiate fx, this curve with respect to f, x, when it is equals to 0, then this point is said to be turning points or maximum point or minimum point. And this is also said to be stationary point. Okay, now see, to find the coordinates of these points, if you want to find out the coordinates of these points, we need to differentiate fx to find the gradient function. Number 2, solve f prime x equals to 0, as this represent the gradient being 0, and substitute the values of x into the original equation to find the corresponding y coordinate. If you want to find out the coordinate of this stationary point or turning point or the maximum minimum point, at first we have to differentiate this fx. So fx differentiate, then fx equals to differentiation of fx, we will write equals to 0. From here we get the value of x, and after that we will put this x value in the original equation to find out the value of y. Okay. You can also find out whether the stationary point are maximum or minimum. If in a question it is asked us this stationary point is maximum or minimum, what will you do? Points by finding the value of f double prime x. We will differentiate fx 2 times, or fx first time differentiation equals to 0 and second time differentiate f double prime x. If we differentiate f 2 times, we can write this is also in this way, d square y by dx square. Okay, so we will differentiate 2 times d square y by dx square at the stationary point. So now what happened? This is because f double prime x measure the change in gradient. You obtain f double prime x by differentiating fx twice. So if dy by dx equals to 0 and d square y by dx square less than 0 or negative, then the stationary point is maximum. Remember these things. If dy by dx equals to 0 and d square y by dx square less than 0, then the stationary point is maximum point. if dy by dx equals to 0 and d square y by dx square is greater than 0, then the point is minimum. Now again, I want to show you in the board. So how can we find out the stationary point is maximum or minimum? What will you do? Like y equals to fx is the function. At first, we will differentiate it dy by dx, or we can write it as f prime x. So we will write dy by dx equals to 0 or f prime x equals to 0. From here, we get the x value. So which x value we get? We will put in the original function. So we will get the y value. So this x value and that y value will be the stationary point. If any question they ask us whether the stationary point is maximum or minimum, what will we do? We will differentiate y two times. That means we will get d square y by dx square, or we can write f double prime x. So d square y dx square, here we will put the x value. If d square y by dx square value is greater than 0, then the stationary point will be, if d square y by dx square is positive, then stationary point will be minimum. If d square y by dx square is negative, after putting the value of x or without putting the value of x, if d square y by dx square value we get negative, then the stationary point will be maximum. This is the main information from this topic. Okay. Now see how can we solve it. Now we will solve exercise 7, chapter 9, page 153, question number 2. Find the x coordinate of the points where the gradient is 0. Establish whether these points are maximum or minimum points. And number A, y equals to 6x square plus 2x. Okay, now see how can you solve it. Y equals to number 1, question number 2, A, y equals to 6x square plus 2x. So at first we will differentiate y with respect to x. So dy by dx, we will write here d by dx, 6x square plus 2x. We know the differentiate formula, like y equals to x to the power n. So dy by dx, d by dx, x to the power n. Then n come first, n x to the power n minus 1. This is the differentiation formula. So if we differentiate separately, d by dx, 6x square plus d by dx, 2x, this constant come first, d by dx, x square, plus 2 d by dx, x, then 6 is 2x, 2 minus 1 plus 2. Differentiation of x with respect to x is 1. So 2, 6 are 12 here, x plus 2. So dy by dx we will get here 12x plus 2. Now, if we want to find out the maximum point or minimum point, what will you do? At first, we will write dy by dx obviously equals to 0. Because where the maximum point or minimum point occur, here the gradient is always 0, always 0. So dy by dx equals to 0. So 12x plus 2 equals to 0 here. So 12x equals to minus 2. So x equals to minus 1 by 6. So we get the value of x. Okay. Now we want to find out whether the stationary point is maximum or minimum. So what will we do? We will differentiate dy by dx again. So we'll get d square y by dx square. So if we differentiate this d by dx, 12x plus 2, so it will be 12 d by dx x plus d by dx 2. X differentiate with respect to x is 1 and constant differentiate with respect to 1 is 0. So 12. So d square y by dx square is positive. So stationary point is max positive. When it is positive, the stationary point is minimum. So stationary point is minimum. This is a number question. Okay. Now y equals to 10 plus 7x minus 6x square. So if we want to find out the x coordinate and find the whether the station point is maximum or minimum, we will differentiate dy by dx. So d by dx 10 plus 7x minus 6x square. So separately, if we do differentiation, 10, 7 come first, d by dx x minus 6 x square. Constant differentiation is equals to 0. 7. X differentiate with respect to x is 1. 6 into 2x, 2 minus 1. So finally, we get 7 minus 12x. So if we want to find out the stationary point, obviously dy by dx equals to 0. So 7 minus 12x equals to 0. So 12x equals to minus 7. X equals to 7 by 12. So this is the x coordinate. Now, if you want to find out whether the stationary point is maximum or minimum, we'll differentiate this again. So d square y by dx square, we'll get here minus 12. So minus 12 means less than 0. So the stationary point is maximum. This is the answer, maximum. Okay. Now, y equals to 10 minus 2x plus 4x square. So we have to differentiate this with respect to x. So d by dx 10 minus 2x plus 4x square. So we can differentiate separately d by dx 10 minus 2 d by dx x plus 4 d by dx x square. Constant differentiate with respect to x is 0 minus 2. X differentiate with respect to x is 1 plus 4 into x square differentiate is 2x 2 minus 1. So finally we get here minus 4 plus 8x. So dy by dx equals to minus 4 plus 8x. So if we want to find out the stationary point, the coordinate of x coordinate of the stationary point, so dy by dx equals to 0. So minus 4 plus 8x equals to 0. Then okay, so plus 8x equals to plus 4x equals to 1 by 2. So this is the x coordinate. 1 by 4. Wait, this is 2. That one is 2. 2. This is 1 by 4, not 1 by 2. This is 1 by 4. Now we have to differentiate dy by dx again. So it will be d square y by dx square. So we'll get here 8. So 8 is positive, greater than 0. So stationary point is, when it is positive, the station point will be minimum. Okay. F number y equals to x square plus 54 by x square. Uh, if we differentiate, we have to rearrange this x square plus 54. When x square go upper side, it will be x to the power minus 2. So we will differentiate this with respect to x. So d by dx, x square plus d by dx, x to the power minus 2. These two come first, 2x, 2 minus 1, 54. This minus 2 come first, x minus 2 minus 1. So it will be 2x minus 1, 0. Wait. The question is like this: y equals to x square. 54 by x means when it's go upper side, it will be 54 x inverse. Now we differentiate dy by dx. It will be d by dx x square plus 54 d by dx x to the power minus 1. So x square differentiate, it will be 2x, 2 minus 1, 54. It will be minus 1 x to the power n minus 1, minus 1, minus 1. So it will be 2x minus 54 x to the power minus 2. So dy by dx will be 2x minus 54 by x square. Now we have to find out the x coordinate when dy by dx equals to 0. So right here 2x minus 54 by x square equals to 0. So minus 54 by x square equals to minus 2x, minus minus cancel. So 54 divided by 2 equals to x cube. So x cube equals to 27. So x equals to cube root of 27 means it will be 3. So we get the x coordinate is 3. Now we have to find out the stationary point is maximum or minimum. So we have to differentiate dy by dx again with respect to x. So what will we get? We'll get here d square y by dx square equals to, if we differentiate here, it will be 2 minus 54. Minus 2 come first, x to the power n minus 1. So it will be 2 minus, minus multiply minus is plus, 4 2s are 8, 108, x to the power minus 3. So finally we get 2 plus 108 by x cube. Now if we put when x equals to 3, the square y by dx square equals to what? 2 plus 108 divided by 3 cube. So finally get 6. So 6 is positive. So stationary point is when it is positive, d square by dx square. So the stationary point is obviously minimum. So I think everybody understand this maths. This is from your mathematics book. Additional maths students also can take help from this topic. If you have any confusion, you may contact with me. My email address is mohammad.ali.shuman@gmail.com. Thank you everybody for watching. Thank you all.